today's video, we are going to discuss about SN1 and Sn2 reactions. So only with the models, try to understand this. Here I have a carbon attached to 3 other elements and with 1 halogen. It is halogen and 3 are other elements and it is carbon. Now this is called primary alkyl halide. So if it is reacting with any nucleophile, what is meant by nucleophile? Which is looking after or looking for a positively charged species. Now this is carbon, this is halogen. As it is more electronegative, it is partially negative, this is partially positive. Now there is a possibility that there is one more nucleophile like OH minus, any Cn minus, I minus, Br minus, any better nucleophile than this. Try to replace this from this and this gonna attach here. Now possibility, if it is trying to come from this direction, this is a halogen, it has a lone pair of electrons. It is also nucleophile which is negatively charged. These two will repel. So from the front side, attacking is not possible for incoming nucleophile. Now this nucleophile will start attacking from back side. When it is start attacking from back side and try to donate its electron to the positive center, then it will slowly cleave. In between, it will form a transition state where complete bonding and complete bond making or bond making has taken place. That is called as transition state. But the attacking start from this direction. Now, because of that, once if it is remote, this will attack from back side. So previous it is here, but the new nucleophile direction is opposite. Now see here, when nucleophile is here, hydrogens are this direction. Once if the nucleophile is here, hydrogens are in opposite direction. This is called umbrella inversion. Previous umbrella was like this. Now it is like this. It is called umbrella inversion. Here we have transition state and inversion takes place. You will get a product where inversion has already done. If this is R configuration, if the reactant is R configuration, the product will be S configuration. If the reactant is S configuration, the product will be R configuration if it is optically active. So you will get inverted product finally in SN2 reaction. This reaction completely called as SN2 reaction because this is a reactant, this is a nucleophile, both are participated in one step. Then rate of reaction depends on the amount of this as well as amount of this, concentration of this and concentration of this. Then the reaction is called as nucleophilic substitution second order reaction. So second order nucleophilic substitution reaction because concentration is directly proportional to this as well as this. Yeah, here it is. Now this is a carbon, this is a halogen, and this is connected carbon with its hydrogens, carbon with its hydrogen, and this is one more carbon with the different groups connected. Now this central carbon connected to 3 other carbons in it. Then I call this is tertiary carbon and it is halogen directly connected to the tertiary carbon. So it is a tertiary alkyl halide. Now if tertiary alkyl halide is present, how nucleophilic substitution takes place? If there is an incoming nucleophile, if you try to come from this side and attack, because of existing nucleophile there will be a repulsion, so you can't attack from this side. Then what happens? It will try to attack from backside. But remember, these are single bonds. So freely these groups can rotate. This can rotate, this can rotate, this can rotate. So like fans, these are under rotation, and it will be always crowdy. You can't enter from backside to the center. It is very crowdy. You can't enter from the backside into the C plus. So it is difficult to attack from the backside. Then what it can do? It should wait aside it should wait until this will break and get off. So once, if it is out, if this nucleophile is out, then it will attain a planar structure. So now this, everything is on one plane. Now this can either attack from the top or it can attack from the bottom, either from here or from here. So it can attack opposite to the previous existing one, or it can attack to the same side. So here you will get two different products. One is retention, where the configuration is same as that of previous reactant, or opposite, inversion. So here we will get two products. One is retention and inversion. So this is SN1 reaction, which takes place in two steps. In first step, what happened? There is a halogen which is cleaved. Then you got a carbocation. So tertiary carbocation should be more stable, so it exists. Then it attack either from the top or from the bottom. It gives two products. One is inversion, other one is retention products. So this is SN1 reaction. Why? Because in the first step, this bond has to be broken, and it is not easy because already the reactant is stable. So it is a very slow step, and it is rate determining step. In the rate determining step, we have only one reactant. So this step, rate is directly proportional to concentration of Rx, tertiary alkyl halide. So order of a reaction is only one. It is a nucleophilic substitution unimolecular reaction. So this is a mechanism for SN1 reaction and SN2 reaction. Remember, whenever there is a tertiary alkyl halides, they prefer SN1, and if it is primary alkyl halide, they prefer SN2 reactions. So you take few examples and try which will give SN1 reaction and which will give SN2 reaction, because it is one of the most important topic in organic